Hello friends, welcome back to the channel. So in this video, we will be mainly deep diving into the MCP protocol architecture as well as the different transport mechanisms like the SSE, which is the server sent events with HTTP, and also the standard input output. And also we will be getting into the lifecycle management between the client and the server. And at the end, I will show a demo with a demo for the MCP Inspector, how we can use MCP Inspector, and what are the different key features of the MCP Inspector. So let's get going. Okay, so the general overview of the MCP protocol is like that. We have the MCP client, and then we have the MCP protocol, MCP server, as well as we have the MCP host. Now what are hosts? Now host basically coordinate the overall system, and it manages the LLM interactions. And hosts are the LLM applications, like Cursor, Windsurf, or some other desktop app that expect the data from the server. The key features are that they initialize and manage the multiple clients, and then they also do the client server lifecycle management. So all the interaction between the clients and the server, that lifecycle is managed between the client and the server. And it also handles the user authorization decisions, and also manages the context aggregation across the clients. Because if you are doing an STDIO, that is a standard IO, then you will have multiple servers and one client. The second would be the clients itself. Okay, so the client has a one to one connection, or a dedicated connection between each server, and they connect the hosts to the servers, and also they do the message routing, bidirectional communication, as well as the clients that monitor what server capabilities are, which is basically the dynamic discovery, what is being done between the server and the client. The next are the servers. Now, what is server? The MCP server, they provide the capabilities through the tools, the resources, and the prompts. Servers are the fundamental building blocks that enrich the LLMs with external data and context. So the tools here are basically the executable functions that allow the LLM to interact with the external apps. And tools functions are similar to the functions in the traditional LLM, like we had the function calling approach. And then the resources are any kind of text files, log files, the database schema, the file contents, and the Git history. And prompt templates are the predefined templates or instruction that guide the language model interactions. Okay, so as we see here, the MCP servers then have their own interface with the end applications, which could be databases, or it could be the microservices. For instance, you have Slack, then you can have a local file system, as well as you can have GitHub, or any kind of external database or services. Okay, and the final is the protocol, which is the MCP protocol, and this defines how all these components they communicate. And the protocol message, MCP is using the JSON RPC message types. And then they also have the lifecycle management, that is the client and the server, they communicate. And then the initialization, the capability negotiation, as well as the session control is happening between the client and the server. And then the transport protocol, or how and what the client and the server exchange the messages, these are basically of two types. You have the STDIO, and for which is mainly for the local servers, like you have the file system. And then you have the server sent events, SSE, for hosted servers. Okay, so now let's go to the transport protocol and see how each of these transport protocols operate. Okay, so the first one is the standard IO. So the standard IO here, the communication is over the standard input and output streams. As you can see here, you have basically the write to standard input and write to standard output, as well as you will have the optional logs or the standard errors. So the client and the server, they receive the JSON messages via the standard input, and standard output is the response. And these are mainly well suited for the local file systems, as well as the Git servers which are hosted on the local clients. So now let's see how the HTTP with server sent events operate. So here, this establishes a bidirectional communication pattern over HTTP. Okay, so the server maintains a SSE connection for pushing the messages to the client. So SSE stands for the server sent events, and the client, they send commands via the standard HTTP post requests or the REST APIs, and this enables a distributed architecture with multiple concurrent clients where we have one server and then we can have multiple clients they are connecting with this server, and they are better suited for the hosted servers. Let's go to the next slide. So now let's talk about what is the lifecycle management, which is a key concept to understand how the client and the server communicate with each other. All right. So in the lifecycle management, so this is the overall stages or in the lifecycle management. So we have the initialization phase, and then we have the operation phase where the real communication happens, and then we have the shutdown phase. So, in the initialization phase, the clients and the server, they are mainly negotiating the protocol versions, and they exchange the capability information between the clients in order to share the tools and the sampling with the servers, and then the servers, they share the tools, the resources, as well as the prompts. This feature is basically the dynamic discovery. So let's get into the details of the initialization phase. So as I said, initialization phase will basically have the four stages. You have the connection establishment. Here, what happens is that the client will send an initialize request containing its capabilities, what features it supports, and then the server will respond with its capabilities, which are basically whatever the server's resources, the prompts, as well as the tools are provided by the server. The next is basically the capability negotiation. So the capability negotiation is where we will have a one is to one connection established between the client and the server, and also the dynamic discovery happens. The third is basically the feature discovery. So the cursor requests the available tools via the tools list endpoint, and the server will respond with its exposed tools as well as the resources. And finally, it is the ready notification where the server will send an initialized notification to indicate that it's ready to begin the normal operation. Now, let's go to the next step, which is the operation phase. Now, in the operation phase, basically the host will send basically a message to the client that okay, it will be in natural language. For instance, that okay, I want to access the contents of so and so file, and the LLM in the host will determine its need to use a specific tool. Okay, and then the LLM will send a tool call request in order to basically save the content of, or basically to read the contents of a specific file on the file system. And then the server will create a request in order to fetch the execution, or basically to use the tool which it hosts, and then it reads the contents of the file in order to send it back to the client. Okay, and then the client provides it back to the LLM, and then the LLM will display the results back to the user. So this is how it happens in the operation phase, where the main activity is the tool execution. And then also the resource access. So if the server has exposed any kind of resources, then those also will be fetched and provided to the user using the URI. So whatever URI is mapped to that specific resource, then the based on that URI, the server will fetch that specific resource and provide it to the client. So now let's go to the last phase, which is the termination phase. So in the termination phase, we have a graceful shutdown, as you see here. So the user or basically closes the workspace, or it will disable the integration, and then the LLM or the host will send a shutdown request to the server. The server will acknowledge the with a response, and then the LLM will send an exit notification, and finally the server will release the resources associated with the session. So this is how the overall lifecycle management happens. Okay, so now we are back into our VS Code, where I will be showing you a example of how to use the MCP inspector. So the MCP Inspector is basically a visual and interactive tool which is designed to help the developers to test and debug their MCP servers efficiently. So this is a sample program where, uh, as you see here, we have the MCP server object defined, and then this is basically a Wikipedia reader. So we are using the beautiful soup and request library in order to fetch basically an article given a path to this function, or this tool I should say, and then it basically reads the a Wikipedia article, and then we show it in a markdown. So this is the overall simple um, tool what we have defined, called fetch Wikipedia page content markdown. And then we also have an MCP resource where we have a URI where we have this echo, and then user defined message what we can send, and then the server should return a string like resource echo, and whatever message we have sent, it should append here and send it back to the client. So this will be to demonstrate how to use the MCP resource. And finally we have the MCP prompt. So the MCP prompt are basically the prompt templates where we basically use the arguments and the description, so user can test the prompts with the custom arguments and preview the generated messages. Okay, so here we will be sending a message, and this will also be appending into the string, and the string will be displayed on the MCP inspector. All right, so the environment what we are using is UV. So since I already have the UV environment, so if you don't have a project which is already initialized with UV, you just have to do UV init, and then once you do the UV init, a UV environment will be created, and then you will have the pipe project.toml file which is generated, which is the master configuration file, and then you will also have the UV lock which will provide you with the overall metadata of all the tools and their sources and version. Everything will be whatever is installed in your overall file system, all the data you will get in the uv.log file. Okay, and you should all, so once you do the UV init, you should create virtual environments. For this the command is uvvenv. Once the virtual environment is created, then you will have a .venv folder created in your the project folder, and then you will have to use source.venv, then script and activate. So you have to execute the activate script. Once you have executed the activate script, then you will be inside your virtual environment. As you see here, I am inside the virtual environment called MCP Client Server. That's my master folder. So I'm already in the virtual environment. Okay, so now we have to start our MCP inspector. In order to do that, there is a very simple command. First, you have to see whether you have the MCP tool. So first, you can go to the project toml, and then you can just use beautiful soup. Then I have used the HTML to text for basically the markdown, that is the HTML to markdown, and then httpx or requests, either of them can be used to fetch the Wikipedia article. And this is the main package which we have to use in order to use the MCP client and server. So MCP is defined here. All right, so now in order to launch our MCP inspector, we just have to first see, okay, we have MCP or not. So yes, MCP is there. So the commands are MCP version, dev, run, and install. So what we have to do is we have to say MCP, and then as you see here, we have a command called dev which will run an MCP server with the MCP inspector. So we have to just say MCP dev and then give the name of our file, which is the MCP inspector. All right, so MCP inspect.py. So we say okay, then we will have the starting the MCP inspector and listening on the port 6277. Okay, and it's on the local host. Okay, so we are in the MCP inspector, and this is providing an interactive UI. So it mainly is offering a graphical interface to connect with our MCP servers, allowing the developers to inspect the resources, the prompts, as well as the tools without writing any additional code. Okay, so as you see here, we have the transport type. So this is STDIO or SSE, and then we have the command which will be executed in order to connect to our MCP server. So as you see, the MCP server is already running, waiting for the request from the client. And then we will have the configuration. Here you can adjust the timeouts, as well as you have the maximum total timeout, reset timeout on progress. So these are some available uh, points which we can remember. If we are facing any timeout issues, we can modify them. So let's connect to our MCP server. So as soon as I press the connect button, it says connected. If you go to server, we see that okay, our MCP server was is connected to the client now. You can see the messages. We have received the message from the client, which is the MCP inspector, to this server. Okay, so let's start with tools. So when we say list tools, it will show us, okay, this is the tool which is available in the server, which is called the Wikipedia page content markdown. And this is this function, what we have written here. So mcp.tool fetch Wikipedia page content markdown. Now we have to select the tool and we have to give a path. So let's give a Wikipedia article on Donald Trump. And now let's run the tool. So as soon as we run the tool, so the function is executed, which is the fetch Wikipedia page content markdown. And this is what we have got from the Wikipedia page. And we are displaying it here. So likewise, if it's a complex MCP server uh, tool, then the user will have this specific space in order to see what the server is returning back to the client. Okay, so this is an example of how the MCP tool invocation happens. Now next, see how prompts are. So we can say list prompts. So we see that okay, we have a prompt which is exposed called create an echo prompt. Okay, so as you see here, we have this mcp.prompt echo prompt, and then we have the create an echo prompt is basically the doc string. Now these doc strings are very important because this only tells to the LLM, and it provides a context in order to make the decision that okay, you have to use this, you have to fetch the prompt or the tool or the resource. Okay, so now we see that okay, echo prompt, we go to the message, we will type a specific or maybe a generic message called hello world. And then when we say get prompt, so now we are getting this specific JSON. This is similar to the OpenAI way of working, where we have a messages, and then the messages is basically a list of dictionaries, and inside the dictionary we have role as user and content, where we are also getting the text which our server returned, which is called the please process this message hello world. Okay, as you see here, we are returning the same text back to the client. And lastly, we can see about resources. So we will basically call list templates. We will see, okay, we have one resource which is exposed hello. And when we say read resource, somehow we are not getting it. Okay, now let's go to the resource and see how we can fetch that resource, what is exposed via the URI. We'll say list templates. Okay, let me first see whether our resource is working. List resources. Okay, so we have echo message. Okay, so I changed something here. I observed that when I have the placeholder message, okay, this is, I'm not able to, maybe I'm missing out something, but I was not able to execute this function. So I changed it to a static URI, okay, which exposes, say, a resource, which is this string here. And now we can, if we click list resource, I'm getting echo message. And this is the resource which is coming back, which is the resource hello world. So as you see here, so this is an example of how we can read back the resource, what is being exposed by the server. It could be a file, it could be a database, or it could be anything which is exposed by the server. That's all for today. Hope you enjoyed this video. So please like and subscribe this channel for more such videos.